So 9-6 kind of sums up everything that we've done in the last handful of sections. So you'll get to see in this chart right here all of the forms. So, standard form for circle, parabola, ellipse, and hyperbola that you should be expected to know. There's a form for conic sections that's like a very generic form that any conic section could fall into. And you've seen that form, like we saw it right here with this example that we did. This is the conic form. And so I'm going to write that down. It looks like this: ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Lots and lots of variables there, lots of pieces going on. So all those capital letters, A through F, those are all constants. And so you can see here, like the number in front of the x squared, that's A, so that was 25. C was -4, there was no B. D is -100, E is 48, and then F was -144. So this is our conic form. We want to eventually turn it into this form right here, which we consider to be standard form for a hyperbola. So I'm going to write down all of the standard forms that we have here. So for circle, we only have one standard form. It's x minus h squared plus y minus k squared equals the radius squared. And then for the other three, for parabolas, ellipses, and hyperbolas, we have two different sets for whether the function is in horizontal form or is in vertical form. So if we sneak, let's see. So I'm going to write all the horizontal forms here under this column and write the vertical forms here. So horizontal and vertical. So the parabola's horizontal form looks like this: y equals a times x minus h squared plus k. The vertical form is x equals a times y minus k squared plus h. So everything kind of switches around there. The ellipse, we have some similar forms there. So the ellipse, we've got x minus h squared over a squared. It's the fact that the x is attached to the major axis. That's what makes it horizontal. And then the y is attached to the minor axis, the length of the minor axis, I guess. And then here, those two numerators just flip-flop. So if it's vertical, that's because the y stuff is attached to the major axis, and the x stuff is attached to the minor axis. And then finally, hyperbolas. Let's get some lines in between these. Whoops. There we go. So now the hyperbola, if the x is first and it's the positive one, then we have minus y minus k squared over b squared. That's what makes this one horizontal. And then here, this one is vertical if the y stuff is first. Okay, so these ones, very subtle difference between these formulas, but obviously it makes a huge difference in terms of the graph. So let's practice one more of these where we turn it into standard form by completing the square. So just like I did in the previous set of notes, we can block off, here's some x stuff right here. Here is some y stuff right here. And then here is a constant that we are going to boot over to the other side. It's just getting in our way when we're trying to complete the square. So let's gather up our x stuff. But remember, you cannot have anything in front of the x squared, so I'm going to pull it out. So here when you factor out a 4, we're left with an x squared. Here when you factor out a 4, we're left with a -4x. Leave a space, you know that's coming. And then for my y stuff, there's nothing here that I can't have. So I'm not going to factor anything out, I'm just going to group my y stuff together. And then leave a space. And finally, I am going to take that -4, add it to both sides, so that I have a 4 over here on the right. Okay, so exact same stuff that I had right here, just a little bit of manipulating and rearranging. So here, inside the parentheses, I'm going to complete the square. So I start with that negative number, I cut it in half, and then square it. So half of -4 is -2. When I square -2, I get +4. And hopefully this is so familiar that it's almost annoying by now. Remember, this isn't really a 4, it's 4 times 4. So since I just put in a brand new 16, I have to put a 16 over here as well to keep the balance going with my equation. Now here, I start with my middle number, cut it in half, and square it. Half of 8 is 4. 4 squared is 16. Now, this actually is a 16 because there's nothing on the outside. So I just balance with a 16. Now, simplify it up. We keep the 4 right here. This, what multiplies to 4 adds to negative 4? That would be negative 2 and negative 2. So I can write this as x minus 2 squared. The shortcut is to just take half of this number for this number. Plus, this is y, half of 8 is 4. Or in other words, what multiplies to 16 and adds to 8? And that would be positive 4 and positive 4. That's why I have 2 of them. 4 plus 16 is 20. 20 plus 16 is 36. Now, here's the weird thing. If you look at this, these all have slightly different forms. This definitely is not a parabola. We know that much. It looks nothing like this. But it has, these. So it could be circle, ellipse, or hyperbola. Here's the big difference. The circle just has one radius squared over on the other side here. It doesn't have anything in front. So it's not a circle. So what I do, since I know it's either an ellipse or hyperbola, this has to be a 1. So I'm going to divide both sides by this 36. Okay, so divide everything by 36. The 4 over 6 reduces down, so I have x minus 2 squared. 4 over 36 leaves me with a 9. Plus, and then y plus 4 squared over, that is just a 36, because it doesn't have anything to reduce with. And then 36 over 36 leaves me with just the 1. So this is my final equation, so that's part of my final answer. And then if I look up here, you can see that this, the addition versus the subtraction, is what makes it an ellipse. Okay, so this is an ellipse, also part of my answer. And then finally, we're asked to graph as well. So if we look at these features right here, the center is positive 2, negative 4. So I can start there. Okay, and just like the other ones, all I'm going to do is mark it. I'm not actually making it a point because it's not a point on my ellipse. It's just the center. And then what I do is I look down here. So here this is a squared. So if a squared is 9, that means a is 3. This is b squared. So if b squared is 36, b is 6. So that tells me how many units to go up, down, left, right from that center in order to form my ellipse. Okay? So here we've got this is a 9. It's underneath the x. That's a left and right thing. So I'm going to the right 3 units. There's my first point. Then I go to the left 1, 2, 3 units. That's my next point. Then I'm going to go up and down this many units. Okay, so I go up 1, 2, 3, 4, 5, 6. Spot right there, and then sneak in 1, 2, oops, let's pretend that I made it all the way down 6 units. So when I graph my ellipse, it's actually going to go a little lower than that. Okay, so hopefully you left room to finish the ellipse on your paper, because clearly I did not. All right, so that one looks like this. Let's do a quick shortcut on the next page. Shortcut is something called the discriminant. We had a discriminant with quadratic equations. This is actually the exact same formula. The discriminant is b squared minus 4ac. All right, so that comes from this formula that we had right here. So we take this, b squared minus 4ac, and he gives us a whole bunch of clues. All right, so we've got a bunch of different categories here. So category 1, if the discriminant is negative, so the discriminant comes out negative, and b is equal to 0, and a is equal to c. So this one, very, very filled criteria here. Lots of things need to happen for this to be true. If all of this stuff is true, then what I get is a circle. Okay, that's category number 1. Category number 2, let's say again that b squared minus 4ac comes out to be less than 0, but one of these things is not true. Okay, so then either b isn't 0 or a isn't c. If it doesn't meet this perfect criteria to be a circle, then what we have is an ellipse. Okay, next category, if b squared minus 4ac comes out to be exactly 0, that's a parabola. And finally, the last category would be if this discriminant b squared minus 4ac was positive. If that is positive, I have my final option, which is a hyperbola. Okay, so this is a very quick little method that you can figure out without even rearranging the equation or graphing the equation. Very quick little method that you can use to figure out what type of conic section you're dealing with. So all we have is just a few examples of this, and we're going to figure out which four of these categories it falls into. Quick little note here. When b is 0, which puts us into this category, the conic is either vertical or horizontal. That's all we've even dealt with. Eventually, in your pre-calc future, if you have a pre-calc future, you'll be looking at some that aren't vertical or horizontal. They're kind of like slanted. So picture like an ellipse that's slanted a little bit, or a parabola that's slanted a little bit. We're not dealing with those today, but just kind of a fun fact for you. So last example, example 2. We are going to find b squared minus 4ac. Now be very careful because the book purposely prints these out of order so that you know which one b is, which one a is, and which one c is. B is attached to the xy. Let me actually rewrite our standard form so you know what everything is. Okay, so that's standard form. So b is whatever's attached to the xy. So here it's a 4. So 4 squared minus 4. A is attached to the x squared. So here that's a negative 6. And then times c. C is attached to the y squared, so that's an 8. So 4 squared minus 4 times negative 6 times 8. If you're quick with arithmetic, wonderful. Otherwise, you can just feel free to plug that strand right into your calculator. So let's look. Okay, a bunch of stuff on there, so ignore that. So 4 squared minus 4 times negative 6 times 8. Oops, that's not on the screen, I'm sorry. So we get 208. So 208, look for the category. That is definitely a positive number. And so that tells us that this is a hyperbola. Okay, same thing with part B, and then again for part C. b squared minus 4ac is what we're trying to find. So the b is attached to the xy. We look, there is no xy. So that's just 0 squared minus 4 times a is attached to the x squared. So that is a 3. Then c is attached to the y squared. That is a 2. So again, you could, if you wanted to, just plug that into your calculator. You get a negative 24. Okay, so since it's negative, it falls into one of these two categories. B is equal to 0, but A is not equal to C. So remember, if one of these isn't true, and this is the case that we're dealing with here, so that makes this an ellipse. Okay, so just a quick note, A is not equal to C, which is what makes it an ellipse rather than a circle. Okay, and then finally, our last example here. B squared is whatever's in front of the xy. There isn't an xy here, so it's 0 squared minus 4. A is whatever's on the x squared, and we don't have one of those either, so that's 0. And then c is whatever's on the y squared, and that's technically a 1 here. So this is 0 and this is 0. So 0 minus 0 is 0. And if my discriminant is 0, that makes this a parabola. Okay, so these were quite a bit shorter than what you guys have had recently, so hopefully you love that.